All right, thank you everyone for your patience, and thanks for joining us for our final webinar of 2017. It's been a great year, and many of you on the line today have actually been a part of that, and so we thank you very much. And thanks again for joining our webinar, Simulate is Great, Evaluate is Better. We hope you'll find today's 30-minute session helpful in aiding some of the design, test, and implementation challenges of multi-coax connectors that you may face. And please note that you're able to, at any time, download the TR Multicoax datasheet, as well as the evaluation kit manual from the webinar panel in the bottom right-hand corner of your screen. Those will be available throughout the session today, and we hope that you'll download those and take those with you after our session concludes. Just a bit of housekeeping. We have all attendees on mute, so please submit your questions via the questions box, and we'll do our best to answer those questions during our Q&A session at the end of the presentation. And at the conclusion of the presentation today, you'll be asked to take a short survey. This helps us gather feedback on how to improve future webinars and webinar content. And lastly, we're aware that many of you are taking time from work right now, so we'll do our best to keep the session to the time allotted, that 30-minute time frame. That includes time for questions. So we'd like to get you through this webinar and out of here within 30 minutes. So thank you again for your time and for joining us on our webinar today. Continuing with the housekeeping, I did want to introduce myself. My name is Nat Stevens, and I'm the marketing manager here at Ardent Concepts.
My name is Ben Pratt. I'm in applications here at Ardent Concepts.
And a brief overview of the agenda for today's webinar. We do want to walk you through a brief company profile to let you know who Ardent is and what we do. We want to talk a little bit about the importance of simulation versus measurement, and what Ardent does to support both of those key concepts in design of electrical systems. Which evaluation kit is right for you? So we're going to highlight what we offer for evaluation kits for the TR Multicoax series and help you to establish which one fits best for your design guidelines and your applications. We'll briefly walk you through unboxing and use of the TR evaluation kit. And along the way, we'll hint at some tips and tricks that may help you to both use the TR evaluation kit and understand how TR Multicoax might be beneficial in your application. So who is Ardent Concepts and what do we do? Well, we focus on three main areas. The first being signal integrity. So we're passionate about high performance and we're dedicated to improving data rates for even the most advanced systems. And what does that mean to you? Well, it means that we're focused on an R&D effort to drive data rates higher and to support you with passive components as you're developing faster systems. How do we do that? With our compression mount technology. So all of our products are based on compression technology, which enables higher frequency electronic transmission lines without the use of solder. And what that leads to is cost savings because there are no wasted components and no throwaway as you revise boards or move on to new programs. And finally, performance. Our applications are proven across many industries, including telecom, semiconductor, and test and measurement. And so those are some of the key fields in which we're working in. And our patented technologies, so our IP, have been proven for over 10 years in field use. And we continue to develop patents and ensure that we'll be on the leading edge of new technology as it's developed. Ben's going to talk to you a little bit about our dual compression solderless solutions.
Yeah, so on this slide, we're just talking about the dual compression like you had mentioned in the previous slide. It's kind of the backbone of our whole IP. Our IP consists of a number of contact designs that utilize compression mount technology. And as you can see, it is a truly solderless connection that utilizes the spring-like design to act as the connection between two surfaces. Usually that surface would be a PCB and a DUT, for example. The bottom shows an example of a single-sided soldered down pogo pin. Again, this is outlining again the fact that Ardent's core technology exists in a world without solder. Like Matt had mentioned, cost savings of compression mount technology lies heavily in the zero leave behinds and the reusability of our connectors over multiple platforms. This here is a slide showing the action of our contacts under compression. These are two of our core contact technologies, the CR and the RC. The RC contact on the right, we always get, looks like an inductor, and most everyone kind of calls us out on that. But in truth, under compression, the windings of those springs short and act like a solid contact element, giving ideal electronic and AC performance.
So at Ardent here, our tagline is signal integrity is our passion. And what does that mean to you as a customer? Well, what we do is we use the latest versions of electromechanical simulation software to design a product, an R&D product, and then we prove out those designs with modeling software for prediction of the product performance, and then we tweak those R&D designs and measure them to ensure that they're designed for high volume applications. And where that's really key is that what we're actually doing is taking designs that are given to us by customers and ideas that are brought to us by customers to solve problems, and we're taking those designs and making them into a manufacturable product that can be tweaked and measured to ensure best performance in your system.
Here's just kind of a look at what we have in-house here that gives us our advantage to do all our testing. So we have a number of software capabilities, HFSS, Ansys Mechanical, Allegro. We also have the hardware capabilities of a 40 gigahertz PNA, but also a 67.5 gigahertz PNA. Obviously, as we continue to push forward in the industry, and the industry predicts that we need to get that higher bandwidth, we have continued investment to keep pace with the frequencies our customers are pushing. Taking feedback from the field, like Nat has said, and bringing this in-house to test and R&D and new products as a fit for customer applications is a huge part of our using our lab, but also continuing testing for our repeatability for volume production applications allows us to have a repeatable product and to prove it to you every time.
So what does this mean to you as a customer, and why are you here today? Well, you're here to learn a little bit about our TR Multicoax Series and our evaluation kits for this product that help you test this product in-house. And our TR Multicoax Series offers superior signal integrity from multiple high-speed analog or digital channels. We offer it in a 20, 40, and 70 gigahertz variety. So a little bit more about this product. It's going to offer you those 20, 40, or 70 gigahertz configurations, and users are able to upgrade those connectors as bandwidth requirements on their applications increase. So TR is the highest density, high-speed multi-coax connector on the market. The interface on our connector is compression mount, which drives lower total cost of testing by avoiding costly solder down components that can't be recovered and encouraging reuse across programs. So there's no solder leave behind, no solder block, no individual connectors that are screwed down or soldered to the board. It's a compression mount technology. So the benefits to you as a consumer are a superior signal integrity up to 70 gigahertz, better long-term repeatability of the connector performance, and we'll talk about that a little bit more as the presentation goes on. It's a solderless system, so there's no signal distortion, and it ensures clean signal integrity. So no solder contaminant, no issues with breaking solder joints, and you're ensured that there's no leave behind. It's a quick connection of multiple signals to PCB. So in the image to the left here, you see there's actually some, I believe those are GPPOs. Those individual connectors take time to press in, and they take up quite a bit of real estate space on the board. Our TR Multicoax Series lets you attach multiple channels very quickly to the board. So an easy out-of-box, easy-to-use solution. Higher density gets TR closer to the device under test. And so obviously that's important because it means less length of signal trace out to your individual connectors. In this case, you can have a very short signal trace out to the TR Multicoax connector footprint. There's no more failing of snap-in connectors. So as we mentioned up above, the TR Multicoax connector is very repeatable, and you don't have any signal degradation of individual connectors with the TR Multicoax connector. What's important here is that when the TR Multicoax connector fails, it'll fail hard. It won't have signal degradation like you may experience with some of these individual connectors. And then it's reusable across programs. So as you're doing board spins and board revisions and program spins, you can reuse that TR Multicoax connector across those board revisions. So when it comes to our TR evaluation kit offerings, we offer them in two varieties, the TR70 and the TR40. The 70 for 70 gigahertz applications and the 40 for 40 gigahertz applications. What's included in these eval kits is a TR Multicoax connector. This is an 8-channel connector that we offer in the standard eval kit. 2 Southwest microwave edge launch connectors. In the case of the 70 gigahertz version, they're 1.85 connectors. In the case of the 40 gigahertz evaluation kit, they're 2.92 edge launch connectors, or K connectors. And then our Ardent evaluation board with a TR Multicoax footprint on that. Now these products are both standard in-stock products, and why that's important is that we're not custom building these products for a customer when they request them. Those come and go from customers and are tested in our signal integrity lab before they go out. What that means to you is you know they're repeatable because they've come and gone from multiple customers before they reach you, and they're still in prime working condition. And that's important to note because our connectors are very, very repeatable.
This next slide is just showing you the board stack up of our evaluation boards themselves. We use a 3-layer Rogers 3003 board with an FR4 as being that bottom third layer, mostly there for rigidity. Rogers 3003 is used for a few reasons. Not having glass weave incorporated into it allows less jitter than found in other materials. The lack of weave also allows tighter and more consistent phase length skew. Lastly, the relative lower decay value of 3 allows for better and higher frequency testing.
So what does all this mean to you? Well, we understand that not all board stack-ups are the same, and that's important. What we've designed is our evaluation boards to ensure the best performance of the TR multi-coax connector, but in your system and in your application, you're probably using different board stack-ups, different board materials, and different types of traces. And what we offer in this case is coaxial launch optimization service. So if you decide to implement TR multi-coax into your programs, we offer you a coaxial launch optimization, which ensures the fine-tuned performance of the TR multi-coax connector to your application. So while you're receiving the TR evaluation kit to test the performance of that connector, in system, we provide you with a tool to make sure that you're using our TR multi-coax and that passive component to ensure best performance. So Ben's going to talk to you a little bit about some of the sample procedures for using the TR evaluation kit and some of the measurements you can take with this kit to ensure proper performance.
Yeah, so I'm going to kind of go over what we do here and what we send out with our evaluation kit manual. Here, this initial slide just talks about our measurement setup. As you can see, the frequency span is 0.042 gigahertz to 67 gigahertz. The sweep type is step. Rise time is 14.673 picoseconds. The intermediate frequency filter bandwidth is set at 300 hertz. Points that we're going to be pulling for this is 1601. So we're going to go through obtaining the through measurement so we can get a return loss. And this is the method that we use and recommend in our TR evaluation kit manual. So the thing we'll start with is that the partial resolution of the VNA frequency points must be steps in starting frequency. Adding excessive amount of points will add more noise to the measurement in the system, but it also will increase your time of the measurements. This parameter is determined by the functionality of the instruments and is considered over a wide bandwidth measurement. If more points are required, the maximum start and stop frequency needs to be reduced. Note that the intermediate frequency bandwidth is equal to 1 kilohertz for the new Inrisu and VNAs, and less than or equal to 300 hertz for the Agilent or Keysight PNAs.
Sure, and just an important note here with this initial measurement, the entire TR 6-inch assembly is included, as well as the 0.5-inch long microstrip trace, and it's on Rogers 3003 10-mil core, and the edge lodge is included as well in these initial measurements, these through measurements.
So obtaining the through measurement, this here is kind of the procedure for hooking your VNA and test measurement equipment up to our evaluation kit and TR. Carefully connect the VNA test cables to the end launch port, channels 1, 2, 7, or 8. Make an initial connection by hand, and then we say once that initial connection is made and you get it tight and consistent, then pull in an 8-pound-inch calibration torque wrench that comes along with your silk calibration kit. Holding the board in one hand, we ask that you continue to tighten until you get that torque wrench to pop on you, and then you will know that the connection is secure. After the connection to the instrument cable, ensure the quality of connection is visually verifying the end launch is still secured to the end board. And
Ben, if I may interject here, that's an important note here. So we ship our evaluation boards with edge launch connectors, be them 1.85 or 2.92 edge launch connectors. These are available to be moved around the evaluation board. We have multiple traces coming off of that TR footprint. With that being said, it's essential that you align those edge launch connectors very carefully, because with misalignment, there's signal degradation. And what that really does point to is actually an important note, which is that something like the TR multi-coax connector, our connectors offer fine alignment with dowel pins, and you won't have any issues like that. So eliminating the need for these edge launch connectors or individual connectors that have to be aligned isn't the problem with something like the TR multi-coax. And that's something to note and something to think about in your designs.
So next, you're just going to connect the port 2 instrument cable to the coaxial cable of the TR device itself. This does not need the torque wrench. This is something where it's just necessary to get a nice hand tight on there, but we do not ask you, if you feel it's unnecessary, to torque to the connection to the 8 pounds per inch. Observe the S parameter response, the initial measurements we use to obtain the reflection characteristics of the TR device. With this measurement, we also see that the insertion loss is linear across the bandwidth of the measurement. So here is a look at the graph of insertion loss. This is not de-embedded, obviously. As you can see, the signal starts to lose its way a little bit as it crosses 40 gigahertz mark. This can most likely be attributed to the VCB and the trace, as we have the whole connector outlined here.
But it's important to note the stability and the slow grade of the insertion loss there.
Again, you can see that this is our return loss that we're pulling from this first measurement. Again, the variance starts to waver a little bit after 40 gigahertz. Again, this can be a PCB and a trace problem
function. And sure, and we'll look at this a little bit more as we de-embed the connector from these measurements.
So here's the time domain reflection. This TDR is what we're going to use to kind of gate, using a gating function of our VNA to isolate the TR device so that we can get a true return loss measurement.
Great. And so these through measurements are an important first step before we go through and de-embed the TR connector from these measurements and understand really what the loss of the TR connector as a whole is. And in this case, what we're going to be looking at is de-embedding and the characterization procedure for that. And what we're going to be de-embedding is the TR block, the coaxial cable, and the coaxial connector on the end of the TR multi-coax connector. So Ben's going to talk a little bit about the procedure for that as well.
Obtaining the de-embedded reflection parameters with time domain reflection on the VNA. So this slide, we're talking about the S11 and S22 start and stop gates. And are they accurately predicted here? Because our experience and history of obtaining these measurements, our TR is very consistent from device to device. The Rogers 3003 also gives us a consistent base to go off of. This repeatability paired with the instrument's pre-settings mentioned in the previous slide allows us to give you an accurate prediction. As you can see, with an S11, the start gate is at 0.1 nanoseconds, so we go from 0.1 nanoseconds to 2 nanoseconds. With the S22, the stop gate is at 1.57 nanoseconds, so we go from 0 to 1.6 nanoseconds. Fine-tuning of the gates may be necessary, it most often is. If properly placed, the impedance of the device will show altered or non-standard results if those gates aren't in the right spots. The cable assembly is the best one to read. You can see where it should be at the 50 ohms, and that's where the signal of the TDR is kind of leveling out. Sometimes if those gates are off in any direction, you might be at like 53 ohms. Tuning in the gates, moving their locations, will bring the TDR to a more accurate representation of the TR device. Using the cable portion of the assembly as a guide, you can help accurately predict the locations of those gates by getting the cable sending close to that 50 ohms impedance that is expected. Once you have the TDR and everything's locked in, then inverse transform is then turned off, and we switch from the TDR to the frequency domain. Next, we're going to kind of go through the shorting method. What we use for the shorting method, this is how we can get our return loss, which then we're going to use a divide by 2 method to get our insertion loss. So obviously, first we're just going to disconnect the VNA from the last TR testing, connect the 50 ohm load to port 2 in the instrument cable, and then connect port 1 to any of these 3, 4, 5, and 6 channels, as the flooded ground plane of the PCB will cause the short. Select the S11 response to examine the response. The divide by 2 method is applied to this S11 response. First, we kind of get an average value of the response by taming and applying the smoothing function. With the smoothing function, the response is tuned until we see an accurate representation of the insertion loss. Once we get that S11 measurement, and we save it as a CSV file, the obtained phase component select the group delay of the phase unwrap measurement format, save the S11 measurement as CSV file, open the CSV file, and multiply the magnitude by 0.5. Open the CSV file of the group delay and unwrapped phase and multiply the time by phase values of 0.5. Convert the processed group delay time values of unwrapped phase. The de-embedded insertion loss parameter is now composed of the process CSV file data placed into the new S1P file with magnitude and group degrees. I know this is a lot of technical data, but again, as Nat has mentioned, you can download our TR evaluation kit manual, and it has all this information in it for you. I just wanted to give you guys a broad understanding of how we hook up each and every measurement.
So let's take a little bit of a look at the de-embedded results with the TR connector, and Ben, I think you can walk us through the return loss first.
So here you'll see the return loss. Again, this is us de-embedding, so we've set the gates in, and we have eliminated from the ground block of the TR, or the interface of the TR, sorry, and from the SMA, SMB, or SMK connectors of one side. As you can see, it's a much cleaner and smoother signal, sticking down underneath that -20 dBs all the way out to the 65 gigahertz.
It's important to note here that a lot of the loss is probably a function of the coaxial cable as well, and not the performance of the TR multi-coax interface or Ardent's IP. Generally, we say that it's about half a dB per loss in insertion loss per foot for the coaxial cable, and so we'll look at that a little bit in the next insertion loss slide.
So yeah, again, like Nat said, a lot of our marketing material on our website is done with 3-inch cables, and all this measurements what we're doing here and showing you today is with a 6-inch cable. So you'll see a little bit of variance from what we have published on the website, or maybe in some sort of data sheet to what you're seeing here. But as you can see, even with this de-embedded insertion loss, we're still at -3.5 dB out to 65 gigahertz, which is still pretty solid. This last slide here, we're just showing you how to take the de-embedded S2P file of the TR assembly device. Right. So this is just the nitty-gritty of getting the data that you have collected through these different measurements, putting them into a file to have a finalized S2P file for yourself. Open Excel, in each data column, add the de-embedded S11, S12, S21, and S22 data. Representing each parameter in each column should have a magnitude column and a phase column. Open Notepad and add a touchstone file template. Copy the de-embedded file data from Excel into the Notepad file. Save the Notepad file with the extension S2P.
Excellent. Well, we're right up against it. I think we've kept you to our allotted time frame, but we wanted to highlight a quick summary of what we covered today and then focus on some of the questions. So in summary, as signal speeds increase, the need for customers to rely more heavily on measured data and not just simulations is increasing. And what we aim to provide you is a tool in order to take a look at our TR device, measure it in-house, and think about how to incorporate that into your systems. Ardent offers TR multi-coax evaluation kits, and this allows prospective customers to measure the AC performance of both the TR40 and the TR70, so you can choose the evaluation kit that's right for your application. Evaluation kit users have the ability to obtain through measurements of the entire evaluation kit, but more importantly, perhaps, de-embedded results of just the TR multi-coax connector for use in their system design. So you can actually de-embed that connector and pull out the loss of this passive component. And Ardent can also work with customers to optimize their PCB launch upon implementation of TR multi-coax. So once they've vetted the TR multi-coax connector for their system and they look to implement it, we offer optimization services to help you make sure that TR can be designed into your system effectively and without issue. And with that, we'll conclude today's presentation. We do want to make a quick note to have you join us at DesignCon in booth 420 from January 30th to February 1st. Ben and I will both be there, and we welcome you to come join us and ask any questions you might have regarding TR multi-coax. That concludes our presentation segment of the webinar today. We'll now open the floor up for questions. And with that, I'll go ahead to the questions box and see what we have here. One last thing before I do that, I do want to make note that we will be releasing a customer portal, which will house both all of our webinars, our footprint and connector drawings, our application notes, case studies, and additional resources. And those will be available to all customers, and we're looking to release that at the start of the new year. So more information on that to come, and keep an eye out for that. But with that, we'll go to questions. And it does look like the first question we have here is probably the best one we'll get all day, which is, how do I request an eval kit? And so I'll take that one, Ben. The easiest way to request an eval kit is to reach out to us at info@ardentconcepts.com. You can see the email here on this last slide. And we can put you in touch with your regional sales director, and they can help accommodate that request. So that's the easiest way to get an eval kit. Another question I see here is, can I buy the eval board on its own? Ben, do you want to take that one?
Sure. Yeah, you can buy the eval kit on your board. We find that saves our customers a lot of engineering time and cost savings. It's also a great troubleshooting device. If your TR is within your system and you're having issues, getting a TR evaluation board out to you and you being able to de-embed and check your TR device to see if it's causing any of these said problems, it's a great troubleshooting device for our customers, and we highly recommend it. If you want to buy one, go ahead and do it.
Awesome. Thanks, Ben. Oh, another good one. Board footprint materials. For eval, what do you request? What do you use for your eval board? And also, when you're making production and test boards, what do you use?
We use ENIG on all our test boards and our eval boards. We recommend to our customers to use hard gold. Obviously, with our compression mount technology, the contact is constantly making contact with your signal pads or what have you. So a hard gold is going to give you a longer lasting finish. But the truth of the matter is, with our ENIG, we have cycled that up to 1,000 times and had no problems with the repeatability whatsoever. It's just we've always recommended hard gold, but for all our own internal use, we use ENIG.
Excellent. And it looks like we have just enough time for one more question here, which is about calibration structures. Should you use the TR eval kit for calibration?
No. The TR evaluation kit is just for de-embedding the TR. It's for making sure you're getting the proper signal and de-embedding that TR fully so you can take it out of your measurement so you can just get the cleanest possible signal and the best measurement. We've had a lot of customers that have designed their boards around calibrating the TR, but we do not recommend using the evaluation kit as a calibration for the TR itself.
Sure, and we definitely find that most of our customers design their own calibration structures, whether it's a through line or a TRL is what we're typically finding our customers to do. And with that, it looks like we've hit our time limit. We want to thank you again for attending our webinar today. We certainly appreciate you taking the time out of these last few days of 2017 to visit with us. Again, if you have questions, don't hesitate to reach out to us at info@ardentconcepts.com or visit our website at ardentconcepts.com, and we'd be happy to support your needs. Have a great year, and thank you for attending today, guys.
Thank you so much, guys.